Hello everyone, this is Velodreamer. Today I'll talk about a bicycle trailer used together with a Velomobile. So I bought the trailer because there's no space for a child in my Velomobile. I don't like cars and prefer a Velomobile whenever possible. This trailer is one of the cheaper ones and my daughter has almost outgrown it. But the trailer itself is not bad. It even has suspension. It's attached like this. This is a safety strap. The manual says the recommended speed is no more than 15 kilometers per hour. As you'll understand later, that makes sense. I want to show that the trailer doesn't follow directly behind the Velomobile, but slightly to the side. That's because of this hitch mechanism, which is actually meant to be used on a regular bicycle. Since it usually attaches back here and not at the center. But on a Velomobile, the trailer ends up quite far to the right. And that's a problem because it blocks the right side mirror. Especially here where there's left-hand traffic, that's a big issue. And here you can see the light is still visible behind the trailer and also the camera. The camera is mounted higher than the trailer, so from the cockpit I can see what's going on inside the trailer when the child is in there, which is very important for me. You can hardly see anything in the mirror, but the rear view camera solves the problem. And you can also see what's behind since the camera is above the trailer, but you can barely see the turn signals. In fact, you can't see them at all. Of course, the most interesting part is the aerodynamics. How much worse do the aerodynamics get with the trailer? Well, that's what I'll show. To make the test as relevant as possible and eliminate the influence of weight, I want to measure only the aerodynamic impact of the trailer itself. I'll use ballast. The trailer weighs 11.8 kilograms, as you can see now. I used water bottles to match that weight. The ballast will first ride in the trailer up to the test section, then I'll unload it into the grass and drive with the trailer without the ballast. And when I test without the trailer, I'll put the ballast inside the Velomobile so that the total system weight stays the same. That way I can be sure that any change in energy consumption is caused only by aerodynamics, not weight. So, I'm ready for the test. Here I'll I'll leave the trailer in that abandoned house over there. And the bottles can stay here. So the first task is to ride with the trailer, but without the bottles. I'm taking the bottles out, the ballast, removing everything that shouldn't affect the weight. The main thing is to make sure no one thinks it's trash and takes it away. So we're doing the test in real-world conditions. First test, using low gear, the lowest gear, riding with the motor, accelerating with pedals up to the test section. And the test section begins. We press the lever and go. Speed is 20. Now I can relax a bit, of course, and open the window. This will take some time. Let's try the maximum speed that the Velomobile with the trailer can deliver. These sports cars are about to pass. First, I accelerate using the pedals. Well, that was interesting. After pedaling up to speed, I shifted to a high gear, stopped pedaling, and turned the motor to maximum. The speed barely reached 26 kilometers per hour, and on the climb, it dropped to 20. I really wanted to help with the pedals, but of course that wasn't allowed if I wanted to keep the test results accurate. The watt meter, however, consistently showed 600 watts. In everyday riding, I very rarely see more than 350, and usually it's around 260, so 600 watts is a lot, especially for such a low speed. I started to worry that the motor might overheat and burn out, since there's no airflow around the motor inside the Velomobile cabin. When the hill ended, the Velomobile accelerated to 32, then even 36 kilometers per hour, and overall it held a speed of about 33 until the turnaround point. But during the turnaround, I created a dangerous situation by making a turn in the wrong place. I was looking at the camera screen, but apparently due to the low resolution, the small screen, and the fact that the car behind me was black and had its lights off, I didn't see it at all. That sucks. I didn't see it in the mirror either because the trailer blocks it. So I got lucky that it was far enough away and there was no accident, but it was a potentially dangerous situation. After that, I started leaning out of the cabin every time before making a turn. So the camera is helpful, but mirrors must also be visible and usable. The most dangerous part was that the car behind, the driver, couldn't see my turn signals because they were blocked by the trailer. So for him, my turn was completely unexpected. So that's a lesson for me and for the viewers. On the way back, the speed was higher, and at the end, there was a small descent before the finish line, and it reached 40 kilometers per hour. The wind blew off the trailer's rain cover, and that might have affected aerodynamics. But since it happened at the very end of the test, I didn't redo it. Also, about halfway back, I clearly started to smell something hot, like hot oil or machinery. I hoped it wasn't the motor. The average speed in this test was 33.2 kilometers per hour, and the average power 603 watts. All the energy that turned into heat is lost energy, and we'll see that on the graph when we analyze the results. I'm curious to try touching the motor to see how hot it is. All right, Let's touch it. It's hot. Whoa, damn. No, I need to take a break. I wasn't imagining it. It really smells like a hot motor. This is how it can stay half tilted like that. Last test with the trailer wasn't particularly interesting. I used a lower gear, a middle one, and the speed wasn't much lower than at maximum. But the load on the motor was significantly lower. This time during the turn, and for all the following turns, I would start turning, then stop, and check that no one was coming from behind. And since I had already started to turn slightly, they could also see that I was about to turn. Test result. Speed, 31.6 kilometers per hour, power, 465 watts. Of course, that's still a lot, but at least it's not 600. And that concluded the tests with the trailer. I unhitched the trailer, hid it in the abandoned house, and started testing without the trailer. Now I'm loading the ballast so the Velomobile has the same weight as if it were towing the trailer, but without the aerodynamic component. The tests without the trailer weren't remarkable. I just did runs back and forth, again at maximum speed, at medium gear, and at the lowest gear to get 3 data points for the graph. Of course, the Velomobile rode much better, much easier without the trailer, even though the total weight was the same. And here are the results. You can see them on screen. Let me show you my test section. The test section is, by the way, I don't remember exactly how long. Let me check. I made a table a long time ago and forgot the value. So here it is. Total length is 4.44 kilometers. That's both directions. Here is the starting line, and here's the spot where I stand before the start and accelerate with pedals up to this point. Here, I switch on the motor. Depending on the selected gear, it sets the speed. I turn on maximum power and keep it, basically just maintain speed. At maximum, it holds speed by itself. I drive through the test section. I chose this section because the terrain is the flattest here. We keep going. And when we reach this spot, I continue riding on motor power. There's a small green post here. As soon as I reach the post, I give a voice signal. Just say stop. And turn off the motor. I turn around somewhere around here. Of course, turning here is not allowed, I know that now, but back then I thought if I turn here, there won't be enough space to accelerate again, so I go a bit farther to make the U-turn. I turn around, ride on the pedals again up to this line. There's a post here too, it's my marker on the left. And when I cross the line, I turn on the motor and ride back. When I reach the finish line, by these markings, which are clearly visible in the video,
Приближаемся к финишу. Скорость 36.
there's also a green post here, but I look at this one on the right, which is easier to see. When I cross this line, I shout stop.
Stop.
So it's recorded in the audio and turn off the motor. Somewhere here, I stop and say the watt meter reading out loud.
Показания. 81,7 часов. 81,7.
And then I turn around again. So I can stop here and start the next test. So after doing the tests, I don't get ready results, just a set of data inside the videos, a set of video files.
Набор данных. Набор видеофайлов.
Later, I open them and review everything in a calm setting. The most interesting thing here is the time.
Средняя передача.
То есть,
Средняя.
когда вот я приближаюсь к
Старт.
точке старт,
I pause the video, go back to the spreadsheet.
возвращаюсь к таблице.
It's already filled in. I messed up by not recording the process of entering the actual test data.
Актуальными данными.
So I'll just show how it's done. The first numbers, that's the time, are entered in the first column. Start run 1, meaning the run in one direction. Here I also write down the temperature during the test. The actual tests with the trailer are these: 1, 2, 3, and these are without the trailer. Oh wait, no, it's the other way around. These are with the trailer and those without. You can tell by the readings which is which. First I enter the time, the starting time, then I find the finish file.
Файл финиша. Вот у нас финишный столбик.
Stop, right here. And I write down this time, 13:38:54. Yes, this one. That's the test. I get the their time. It's this one.
Я получаю время туда.
I do the same for the return trip. I watch the video and get the back time. The table calculates the total time automatically.
Время обратно. Получаю он сам
But the seconds, the table doesn't calculate. I guess I don't know Excel well enough. I don't know how to convert the time in the table from minutes and seconds into just seconds. So I enter this value manually.
время таблицы изменить из секунд только в секунду, поэтому здесь это значение вписано вручную. Потом
After the finish, I also say out loud, as I already explained, the watt meter reading, and it gets entered here.
Ваттметр. Он вписывается вот сюда. И когда у нас есть время, значение ваттметра,
Once I've entered all the data, time, watt meter reading, I immediately get the result. I get the average speed and average power for that segment.
и среднюю мощность.
That's what I need to build the graphs. Now let's move on to result analysis. Here's the table with two graphs. Green is without the trailer, red is with the trailer. If I show it to full scale, it goes up this high. Really high, and that value is 603 watts, the peak. Here we see power on the vertical axis and speed on the horizontal. So the better the result, the further to the right, and the lower it is vertically. Since this is electrical power, I roughly marked electric losses, but in reality, it's more complicated. Electrical losses don't form a simple straight line. They're more complex, and I hope I'll finish this video and the full research on motor efficiency at different power levels.
И тогда можно будет подставить сюда.
Then I'll be able to insert that graph here and calculate the actual physical power based on specific values of electrical power. But for now, that hasn't been done, so just keep in mind that these graphs show electrical power.
Просто имейте в виду, что эти графики показывают электрическую мощность.
That's exactly why this red graph, the one with the trailer,
Красный
rises so steeply at the end,
настолько вертикально в конце.
because I simply hit the power limit of the motor.
Предела мощности мотора и
And as the load increased, it just drew more electricity, but didn't produce more torque.
не производил крутящего момента. Поэтому, как бы, если я продолжаю
So
дальше,
basically, if I kept going, the graph would just go straight up, and the motor would burn out because it would only be generating more heat. In this case, after 400 watts, it barely increased the pulling force. So let's compare these graphs. Why do they intersect here? That's an artifact of my measurement system, because the graph is based on 4 data points. First point, 0. Second, way over here. Third, over here. And fourth, here. These are my 3 test runs. Ideally, I should have done more tests and more repetitions of each test, but I don't always have the time for that. So everything is somewhat approximate, but still gives a good overall picture. Here's what we can compare. First, let's get the point where the trailer actually starts to slow us down, starting, as you can see here, from 10 kilometers per hour.
Начиная, как видно здесь, с 10 км в час. Рекомендуемая скорость буксирования прицепа это 15.
The recommended towing speed for the trailer is 15.
Мы видим
At
разницу
15, we already see a speed difference of 3 kilometers per hour.
30 это неверно.
That 30 is a mistake, it's actually 3.
То есть при 100 ваттах
So at 100 watts without the trailer, we would have a speed of 18.2 kilometers per hour. At 100 watts, again, I remind you, this is electrical power, so the actual physical power is around 40 watts, maybe even less.
но это электрическая, еще раз повторяю, электрическая мощность. То есть реальная мощность там где-то 40 ватт, даже меньше.
And with the trailer, the speed would be only 15.01 kilometers per hour.
14, ну, ну, 15,01 километров в час с прицепом.
That's a
Разница
3
в 3
kilometers per hour
километров.
difference.
Если мы посмотрим на большие мощности, например, на 200 ваттах,
If we look at higher power, for example, 200 watts, the difference becomes 7 kilometers per hour, even 7.5.
7,5 даже. Ну, так, 7,5. На 300
At
ваттах
300 watts, we already have a 10 kilometers per hour difference, and at
разница. И на 400 ваттах мы имеем
400 watts, the difference is
12.
almost 13 kilometers per hour. That's in terms of speed.
Это что касается скорости. Гораздо более интересно у нас зависимость по мощности. Ну вот.
Much more interesting is the difference in power. So at 10, there's not much difference yet, but at 15, we already have a 20 watt increase with the trailer, which is still acceptable.
С прицепом. Но это еще куда не шло, в принципе, 15.
15 is a reasonable speed for a trailer, so the increase in consumption isn't that bad.
На 20 у нас уже
At 20 kilometers per hour, instead of 20 watts difference, it's 52 watts.
52 ватта. 20
At 25 kilometers per hour, the difference is already 100 watts.
А на 30 разница
30, the difference is how much?
5 ватт.
195 watts.
Это уже как
That's like having another person pedaling with you. So as you can see, if we go just a bit further toward the limit, here it reaches the maximum, and the difference becomes 292 watts at a speed of about 33 kilometers per hour.
при скорости где-то 33. это был предел, потому что больше
That
просто
was the limit
мой
because my
предел.
Velomobile with the trailer simply couldn't go any faster. It had reached the motor's power ceiling.
Вот, поэтому не зря рекомендую
So,
ехать
there's a
быстрее,
reason why it's recommended not to go faster than 15 kilometers per hour. It really seems like there's no point going faster because the energy consumption increases way too sharply.
И я еще раз напоминаю, что
And I'll remind you again, these two graphs were recorded at the same total weight. The Velomobile had ballast, and with the trailer, there was no ballast. The overall mass was the same.
Веломобиль был с балластом, а когда был прицеп, балласта не было. Общая масса была одинаковая. Ну еще что интересно.
Another interesting thing we can see on this chart, this is one of the earlier tests after I installed the Continental tires, the ones I'm using now. It's slightly better than my latest test.
После установки покрышек континенталь, которые сейчас стоят, он чуть лучше, чем мой последний тест. И еще
And here's another test, which I did after making the new roof and installing it. That result is an even better. So ideally, I should be comparing these two. And the difference is because of the ballast, the rolling resistance was higher in the last test due to the ballast compared to the optimal setup.
То есть сопротивление качению в последнем тесте было больше из-за балласта, чем в наилучшем варианте. Так что
So if you have the option to carry your cargo inside the body instead of using a trailer, you should do that. It's much more efficient. But if you need to carry a child or a piece of cargo that doesn't fit inside the body, then a trailer makes sense, but only makes sense to ride at 15 to 20 kilometers per hour. Otherwise, you'll use too much energy.
есть смысл ехать не быстрее, чем 15-20 км в час, иначе вы потратите слишком много энергии. Но если
But if you use the trailer as intended, kids really enjoy riding in it. I hope you found this interesting. Thank you all, and goodbye.